Alright, we're going to take a look at combining like terms and what it actually means to combine like terms. I guess before we can talk about what it means to combine like terms, we've got to talk about what a term is. In any expression, equation, function, a term is going to be anything where we have variables and their exponents. They are the same, so they've got to be matching. So both the variable, so let's say if we had a variable x and their exponent, we'll call it x squared, would be the same. So x and x squared are not like terms. You can see down below we've got a couple more examples. We've got a group of like terms here. We have 2x and 45x and x and 0x and negative 26x and x. You can see they both have the same variable and they also have the same exponent, right? Because we know that they all have an exponent of 1, exponent of 1. So these would not be like terms with x squared. The other thing that we need to mention is that constants are all like terms. They don't have any variable, but they are in fact like terms. So 15, negative 2, 27, 9,043, 6/10, they are all like terms. And another example down below of like terms would be 3y squared, y squared, negative y squared, and negative 26y squared. They're all going to be like terms because they all have a variable of y and the exponent of 2. Now we have some examples of unlike terms, so terms that are not like. So although 17x and 17z have that constant value of 17, they've got different variables. X is not equal to z, so they are not like terms. And now this one's probably where a little bit more of the confusion comes from. But if you think about what we said, they have to have the same variable and exponent. So 31y to the 5th is not a like term with 19y squared, which is not a like term to 15y. They all have different exponents. 15y has an exponent of 1, 19y squared has an exponent of 2, and 31y to the 5th has an exponent of 5. And finally, if we look here at combining like terms, 5 and 7 are both constants, so we can combine those. That'll give me a 12. If I look here at the second one, a little bit tougher to see, but if we sort them all out, so 16 and negative 5 are my constants, negative 4x and 8x are another term. They are my x terms. And then I also have a y term, my 3y value. If I look here, let's start with the constants first. I'll do 16 and negative 5. That gives me 11. We'll do my x's next. I've got negative 4x and 8x gives me positive 4x. And then that 3y, I've got nothing to combine it with, so that just stays as 3y. And the rest of my equation I can pull down, put my equals 12 in there. This is as simplified as we can get with our like terms. We've got to keep the constants separate from my x terms, which are separate from my y terms. Now if I look at the bottom problem, I've got x squared plus 3x squared y minus 8x squared plus 4xy. If I look at this, let's start with x squared. X squared, my variable is x. My exponent is 2. I also have a negative 8x squared, so yes, I will be able to combine those. Next, I'm looking at 3x squared y. I do not see any other 3x squared y. My 4xy is there, has the same variables, but remember that x has an x squared. My 4xy does not have an x squared, so that's going to be a separate term. If I simplify this down, I will have, remember we have a 1 here, so we have 1x squared minus 8x squared will give me negative 7x squared. And then the rest of my terms, remember I cannot simplify those down anymore, so I just bring those down. I have 3x squared y, and I have 4x y. That's as simple as it gets. You can't break it down anymore because those are my only like terms.